In this problem, we are being provided with an equation of a parabola. We need to determine the coordinates of the vertex and the focus, its equation of axis and directrix, as well as the length of the latus rectum. Let us begin. So what we'll do, we'll start with the given equation of the parabola. We have 2y squared added to 3y minus 4x minus 3. This will be equals to 0. Now let's keep the terms containing y on the left hand side, and then we're going to transpose negative 4x minus 3 to the right hand side to get 4x plus 3. Now what we'll do, we're going to divide each terms by 2 so that we get y squared plus 3 over 2 times y equals to 2x plus 3 over 2. Fine. The reason why we divided by 2, because we want to keep the coefficient of y squared as 1, and that's going to help us convert it into a perfect square by completing the square. So that means we're going to rewrite the second term, that's 3 over 2 times y, as 2 times y multiplied to 3 over 4. Now this number 3 over 4 is going to, this is the hint that is telling us that we need to add the square of 3 over 4. And then, that being an extra term, we also need to subtract it. So we're going to subtract 3 over 4 whole squared from it. And the right hand side, that's as it is, 2x plus 3 over 2. Now, we can combine the first three terms. That's the expansion of y plus 3 over 4 whole squared. So this will be equals to 2x plus 3 over 2. We are going to transpose negative of the square of 3 over 4. So that means we have 9 over 60. So that's going to give us y plus 3 over 4 whole squared equals to 2x plus, we're going to combine 3 over 2 with 9 over 16. We're going to get 33 over 16. Furthermore, what we will do, we will keep the left hand side as it is. We have y plus 3 over 4 whole squared. And we're going to take 2 as the common factor from the two terms on the right hand side. So we have x added to 33 over 32. Fine. Now let this be equation number 1. Here we're going to substitute x plus 33 over 32 with x in uppercase and y plus 3 over 4 with y in uppercase, such that equation 1 now transforms into y squared equals to 2 times x. Now as you can see, this is in the standard form, y squared equals to 4ax, which means if we equate the value of 4a, then a comes out to be equals to 1 over 2. This is a value that we'll be using. Now the whole reason what we've done is, this is the equation of the parabola expressed in the standard form, and with this equation we need to find out the focus, the coordinates of vertex, equation of axis. We will do that, but since the coordinates of the vertex are shifted according to equation number 1, so what we have done, we have transformed it to y squared equals to 2x, so that it becomes easier to evaluate the coordinates of the vertex and the focus and the rest of the parameters. So we will first consider the graph of y squared equals to 4ax. This is a right facing parabola. So here we have the graph of the parabola y squared equals to 4ax. Now let's go through the parameters that are used here. So the vertex of the parabola will be at the origin 0, 0. The coordinates of the focus will be at a, 0. And we have the line on which the vertex and the focus lie. That line is referred to as the axis of symmetry line. And since the axis of symmetry line is along the x-axis, its equation is given by y equals to 0. Now, on the same axis of symmetry line, we're going to consider another point with coordinates negative a, 0. And through this point, we're going to pass a line which is going to be perpendicular to the axis of symmetry line. And this line is going to be also and this line will be referred to as the directrix line. So its equation will be given by x equals to negative a. Then we have the latus rectum, which is the straight line passing through the focus of the parabola and perpendicular to the axis of symmetry with its endpoints on the parabola. Now for this particular parabola, if we consider a to be 1/2, then we get y squared equals to 2x. So this is the parabola that we are concerned with. Now this particular parabola has been expressed in terms of the new coordinate system, that is x comma y. But our goal will be to transform it back to the old coordinate system, that means represent in terms of x comma y. So that's a very simple task. So to begin with, we'll start with the vertex. So the vertex is at 0 comma 0, as it's mentioned in the diagram here, which means that x corresponds to 0 and y corresponds to 0. Now in the old coordinate system, what we'll do, we'll use the same two equations, x equals to 0 and y equals to 0, but in place of x, we're going to use x plus 33 over 32, and this will be equals to 0. That's going to give us x equals to negative 33 over 32. And then we have y equals to 0. So y equals to 0, we can use y plus 3 over 4 equals to 0. So solving for y, we get y equals to negative 3 over 4. So that means the coordinates of the vertex with respect to the old coordinate system is going to be negative 33 over 32, and the y coordinate will be negative 3 over 4. So we have successfully obtained the vertex of the parabola. Now coming to the focus. So the focus is at a comma 0. So here a corresponds to 1/2. So we're 1/2 comma 0. This means that the value of x, that's going to be 1/2. Value of y, that will be equals to 0, which means that in the old coordinate system, x equals to half corresponds to x plus 33 over 32. This will be equals to 1/2. Or solving for x, we get x equals to minus 17 over 32. And since we have y equals to 0, that's going to give us y equals to negative 3 over 4. So that means the coordinates of the focus in the old coordinate system is going to be negative 17 over 32, comma, negative 3 over 4. Now coming to the axis of symmetry. Now here, in the new system, axis of symmetry has the equation y equals to 0, but we'll be using the old coordinate system where we are going to replace the value of y with y plus 3 over 4. This will be equals to 0. So this is going to be the equation of the axis of symmetry in the old system. Coming to the equation of the directrix, so here we have x equals to negative 8. That means we have x equals to negative 1/2. All we have to do is replace the value of x with x plus 33 over 32. That's equals to negative half. So when we solve for the value of x, we get x will be equals to negative 49 over 32. So that means our equation of the directrix will be x equals to negative 49 over 32. And then finally, we'll to obtain the length of the latus rectum. So length of the latus rectum of the parabola is going to be absolute value of 4 times a. Now a value is half, so that means length of the latus rectum will be 2 units. And it doesn't matter which coordinate system you use, be it the new system or the old system, the length is always going to be fixed at 2 units because the shape of the parabola does not change. So we have successfully obtained the coordinates of the vertex, coordinates of the focus, the equation of the axis of symmetry, equation of the directrix, and the length of the latus rectum of the parabola.